Welcome to the presentation on Geosciences of the Rajasthan Basins, India. The book Geosciences of the Rajasthan Basins, India, is an edited book comprising 9 chapters that underscore the importance of the basin for both hydrocarbon exploration and academic inquiry. Through a range of analyses and tests, the study of the Rajasthan basins has uncovered valuable findings relevant to diverse fields within geoscience. The editors of the book are as follows: Professor Soumyajit Mukherjee, Department of Earth Sciences, Geodynamics Lab, Indian Institute of Technology, Bombay, Mumbai, Maharashtra, India, and Mr. Nihar Ranjan Kar, Council of Scientific and Industrial Research, National Geophysical Research Institute, Hyderabad, Telangana, India. The book Geosciences of the Rajasthan Basins, India, through its 9 chapters, throws importance on the following insights: geophysical and morphometric insights. Gravity anomalies along with morphometric analysis provide an understanding of the study area tectonics, its effect on the watersheds and drainage system. Gravity modeling also gives information on landscape evolution and the presence of gravitational highs and lows in the area, the structural pattern and interpretations on neotectonics. Hydrocarbon potential. The distribution of types of rock and their petrophysical properties govern hydrocarbon generating and storing potential. Lignites from the coal seams in Rajasthan basins have been studied to know their kerogen type and their significance of liquid oil or gas producing capacity. Palaeontological significance. Fossils in an area not only reveal the recent and past plant diversity, but also are an important indicator of paleogeography, paleoclimate, and the evolution of life. The Eocene palm leaves and aspidella along with trace fossils reported from the study sites of Rajasthan Basin help in an understanding of the past. Overall, the book serves as a key reference for geoscientists, supporting both academic and industrial research with practical applications in resource exploration. It also covers structural geology, geomorphology, paleontology, sedimentology and other allied subjects that enhance the subject knowledge of the reader and their application in studying Rajasthan Basin. As indicated by recent publications, Rajasthan basins have become extremely important in hydrocarbon exploration. Several industrial persons and academicians have been working on these basins. The 2 maps depict the geological layout of the Rajasthan Basin. Figure 1 on the left highlights key lignite mines in the Bikaner, Nagaur and Bardmer sub-basins, marked with red triangles. Figure 2 on the right focuses on the Gurha lignite open cast mine in the Bikaner, Nagaur basin, indicated by a pickaxe symbol. This site is notable for yielding the first fossilized palm frond impressions from western Rajasthan, specifically Amazon Orangopet. The book proceeds chapter-wise and unveils new findings that support the geological importance of the Rajasthan Basin and its sub-basins. The first chapter, Geomorphology, Elevation and Gravity Studies from the Western Rajasthan Basins, India, investigates the clues to active tectonics in the region using geomorphic watershed analysis, elevation anomalies, and gravity data correlations. The geomorphic studies were conducted on watersheds chosen in the 3 sub-basins. Tectonics in an area affect a channel's longitudinal profile by developing various breaks and rejuvenation points. The profile curve having highest R-square value is the best fit curves and rank high, indicating high chances of active tectonics in the area. Upon analysis, it is found that watersheds 1 and 3 in Bikaner, Nagaur, watershed 4 in Jaisalmer, and watersheds 1, 3 to 5 in Bardmer are considered tectonically very active. The elevation and gravity modeling in the watersheds of the 3 basins were analyzed as part of geophysical studies. The surface elevation and free air gravity anomaly show a positive correlation in the watersheds, which indicates structurally controlled topography in the area. Rajasthan Basin hosts several lignite mines of geoscientific relevance. Chapter 2, Lignite of Western Rajasthan as a source for hydrocarbons. evaluates the source rock potential of lignite seams from the late Paleocene to early Eocene Pala and Akli formations using petrographic and geochemical studies. Samples collected were first analyzed under a petrological microscope, the result of which shows the dominance of humanite indicating type 3 kerogen and gas-prone source rock. The Van Creveld diagram classifies kerogen type and assesses organic matter maturity by plotting hydrogen by carbon versus oxygen by carbon ratios. For lignites in both basins, it indicates gas-prone type 3 kerogen. The geochemical studies include ultimate analysis and rock eval pyrolysis, which aid in source rock characterization and source rock potential. With the calculation of various parameters, it is made known that the Bardmer and Bikaner Nagaur lignites consist of type 3 and mixed type 2-3 kerogen. Also, the organic matter is considered immature as per reflectance value of 0.40%, total organic carbon of more than 20%, maximum temperature less than 435 degrees Celsius, and the production index value of less than 0.1. Along with the Bikaner Nagaur, Bardmer, and Jaisalmer basins, the Bayana Basin in Rajasthan also offers insights into active tectonics. Chapter 3 is based on morphometric, gravity and bathymetric analysis of Bayana Basin, Rajasthan, India, comprising weakly deformed Proterozoic siliciclastic rocks of the Delhi supergroup. The basin features dissected rivers and varied drainage patterns, reflecting structural influence on fluvial systems. Trellis, rectangular, radial with angular joining of streams and dendritic drainage patterns were observed in the basin on morphometric analysis. 5 watersheds were classified according to their tectonic activity using the index of active tectonics. Results show watershed 4 with rank 1 and IAT value less than 2 being tectonically highly active, whereas watershed 1 with class 3 and IAT value more than 2.1 being low tectonically active. Watersheds 2, 3, and 5 fall in between class 1 and class 3. Gravity in the basin ranges from -35 to 50 milligauss. Watershed 4 shows high positive values indicating dense rocks or intrusions, while watersheds 1 and 3 have low negative values suggesting deeper areas with more sediment accumulation. Bathymetric elevation data over the basin varies between 200 meters on the eastern side to 1000 meters on the western side. On comparing with historical bathymetric data, it is found that the basin has undergone significant changes in elevation mainly due to human activities and land projects. Chapter 4: Morphometric and Geophysical Studies from a part of the Aravalli-Delhi Fold Belt, Rajasthan, India, analyzes topography and gravity anomalies to assess active tectonics. The study uses indicators such as mountain front sinuosity, drainage basin asymmetry, and long profile analysis based on R-square values. Mountain front sinuosity reveals tectonic activity, with straighter fronts indicating higher activity. Front 7, with the lowest sinuosity, is the most active, while front 3 is the least. Basin asymmetry suggests tilting with watersheds 1, 4, 5, 6, and 7 tilt northwest, and watersheds 2 and 3 tilt southwest. R-square values from stream long profiles show watersheds 6 and 7 are more tectonically active, while watershed 1 is less. Elevation ranges from 200 to 1200 meters, increasing from northwest to southeast. Gravity anomalies range from -20 to 100 milligal, with higher values in the southeast. The relationship between bathymetric elevation and gravity anomalies in the Aravalli-Delhi Fold Belt region was analyzed using principal component analysis. Fossils have always proved to be good indicators of paleoclimate analysis. The current Chapter 5 on palm leaf fossils from the early Eocene of western Rajasthan, paleoclimatic implications, discusses the same fact. Palm's fossils have been reported from the Mesozoic and Cenozoic successions in India, but Rajasthan did not show any clues to it for a longer time. Recently, studies conducted by a group of researchers reported first fossilized impressions of isolated palm fronds, identified under the fossil genus Amazoneuron from the early Eocene Palana Formation exposed in the Gudha lignite mine located in the Bikaner-Nagaur basin. The morphological study of the fossil under microscope was done and photographs were taken. The fossil resembles isolated, laterally impressed, unarmed segments of coriaceous palmate leaf fragments, asymmetrical blade, strong prominent midvein, and secondaries running parallel to midvein on either side. The fossil Amazoneuron also gives information on past climate conditions. Modern-day palms stand distributed in the tropics where mean annual temperature is 18 to 28 degrees Celsius and the coldest month mean temperature is more than 18 degrees Celsius. Several fungal remains have also been preserved in the cuticular fragments of present palm fossil leaves. Hence, the presence of Amazoneuron from Palana Formation of Gudha lignite mine and fungal remains indicate a warm humid climate type at the time of deposition. The Paleogene sedimentary record of the Rajasthan basins holds enormous plant megafossils. Chapter 6, Plant Megafossil Diversity in the Paleogene Rajasthan basins of Bikaner-Nagaur, Bardmer and Jaisalmer, a review, is a summarized record of plant diversity which enhances the knowledge of paleobotany in terms of stratigraphy, classification and depositional environments of the Paleogene that prevailed in the three basins. The modern flora in the basins have been divided into tropical forest, tropical dry and deciduous forest, and subtropical mountain forest. Through surface exposures and drill cores, the sedimentary sequences have revealed the important plant megafossils of Paleogene. The megafossil assemblages recorded from the three basins yield angiosperm taxa which help to interpret paleoclimate and paleoflora as the nearest living relatives of them are known with high confidence. Based on such knowledge, it is known that mainly evergreen forest elements, followed by a few deciduous varieties, existed during Paleogene. An increase in rainfall is suggested to change the evergreen type forests of Paleogene to present-day xeric dry deciduous forests in the basin. The past climates, especially the Indian summer monsoon during the Paleogene in Rajasthan, have been inferred using nearest living relative and climate leaf analysis multivariate program proxies. The nearest living relative method estimates past climates by linking fossil taxa to the climate preferences of their modern relatives. The climate leaf analysis multivariate program, on the other hand, uses fossil leaf morphology and statistical analysis to infer past climate conditions. Thus, the Rajasthan basins likely served as a key center for floral exchange between Gondwana and the northern hemisphere during the Paleogene. Present chapter of the book, Paleo-Environmental Significance of Trace Fossils from Pokhran Sandstone of the Jodhpur Group, Marwar Supergroup, Western India, is a study report of 14 trace fossils with their taxonomy, age, and paleoenvironment. The Pokhran sandstone belongs to the Ediacara age and is the local name of Ediacara Jodhpur sandstone. Trace fossils are biogenic structures created in and on sediments by daily life actions of creatures like feeding, resting, escaping, swimming, etc. The 14 trace fossils include Thalassinoids horizontalis, Thalassinoids suvicus, Ophiomorpha nodosa, Paleophycus striatus, Paleophycus heberti, Paleophycus tubularis, Planolites, Planolites montanus, Planolites beverliensis, Monocraterium tentaculatum, Diplocraterium parallelum, Arenicolites statheri, Cochlichnus sanguineus and Thynedium serpentinem. Sedimentological and ichnological data indicate a shallow marine depositional environment for the Pokhran sandstone within the Jodhpur group of the Marwar supergroup in the Pokhran area. Chapter 8 of the book, The Ediacara discoidal fossil aspidella from Sonia sandstone of the Jodhpur group, Marwar supergroup, Western India, and their paleobiological implications, gives a systematic description of partially and fully preserved 100 aspidella fossils. along with their paleobiological significance and global correlations. The Ediacara biota are the oldest complex macroscopic fossils from the late Neoproterozoic, marking the Precambrian's end. Found in more than 40 countries, Aspidella fossils with frond or stem-like impressions attached to Aspidella discs have been reported for the first time from India's Sonia sandstone. For studying the discoidal fossil, morphological details, sizes, and taphonomical features were studied systematically, and fossils containing slabs were collected from the field. These Aspidella of the Ediacara were previously interpreted as inorganic pseudofossil, medusoids, epifaunal animals of the Cnidarian group, holdfasts of polyps and even non-metazoan and microbial organism. The last chapter of the book, Geomorphic and Geophysical Studies from the Sukri River Watersheds, Rajasthan, India, studies the tectonic activeness of Sukri River's watersheds with two morphometric approaches, that is, analytic hierarchic process and index of active tectonics. Rivers are important geomorphic features that help access the active tectonics as they are sensitive to slight changes occurring on the Earth's surface. The Sukri River is a left-hand tributary of Luni River with 7 major tributaries and basin located west of the Aravalli Range. 7 sub-watersheds were studied to get knowledge about the active tectonics in the Sukri River basin. 3 classes of watersheds with high, moderate and low tectonic activity have been obtained. SW4, SW6 and SW7 belong to the moderate class, whereas SW1 and SW2 are in the high class. The SW3 and SW5 are in the low class. The results of both methods give common results which confirm the aim of the study. The basin also shows tilting in different directions. Bathymetric data reveals a height variation of 200 to 1600 meters, however, it does not reveal any specific elevation trend. Several depressions with laterally pinching sand bodies observed around the basin along with bifurcating channels of the Luni River are possibly formed due to tectonics prevailing in the area. Also, the gravity values in the region vary between -10 to 80 milligal. The large difference in gravity has been attributed to grabbanes rather than relating it to the density of rock formations and materials in the basin. As indicated by recent publications, Rajasthan basins have become extremely important in hydrocarbon exploration. Several industrial persons and academicians have been working on these basins. This edited book is expected to fulfill the requirements of exploration geoscientists and academicians. I thank the audience for their patience and kind attention throughout the presentation. Thank you.